Hello, in this video, we're going to look at how to sketch the energy profile diagram for endothermic reactions. Let's say we have reactants, the one that I have highlighted in green, to be converted into products, the one in yellow, and the enthalpy value is positive. When you look at the value delta H equals to positive, then we know this one is going to be, that is an endothermic reaction. So how do we sketch the energy profile diagram? So first, make sure you have this potential energy right here, this axis. So going up means higher and higher potential energy. And down here, you have the reaction progress. So to start, you need to draw the correct shape for the energy profile diagram for endothermic. And the shape would be the reactants will have lower potential energy, and you'll have the bump going up like that. And then you will have the energy for product to be higher than the reactants. Draw the dotted lines. Okay. And then what you need to do next, you need to label the reactants right here and products on higher potential energy. Okay, so you get your reactants there and the products on that side. The next step is to label, so identify the activation energy. So the activation will start from the top of your bump, okay, from the peak of that bump. Then it will be until the reactants. So this is the EA, okay? So the EA is bigger than exothermic. And next, you need to identify where is the delta H. So the delta H value in here will be between this product line and the reactant line of potential energy. So the delta H value will be right here. So delta H will be equals to positive. And do you remember the EA over here? The EA will have the units of, you're going to have a number over here, units of kilojoule. So this is how you're going to sketch the endothermic energy profile diagram. Now let's have a look at one real example for endothermic. Right here, we have NH4 and O3 solid to be converted into aqueous ionic species. And when you look at the delta H value, it is a positive value, and that is the indication this reaction is endothermic. You will have your reactants, which is NH4 and O3 solids, to be at lower potential energy to compare with the products over here at higher, and the EA value will be from the top here until the dotted lines for reactants, and the delta H value will be between the product line, potential energy line, and the reaction reactant potential energy right here. So you will have delta H equals to positive. A very good tip for endothermic reactions, if you want to find the activation energy for reverse, remember this potential energy, this activation energy over here is for forward reaction. So if the question wants you to find EA for reverse, how are you going to do that? You're going to take the value of EA forward and you're going to minus with delta H. So you're going to take that value and that value, and you should be able to find out the EA for reverse reaction.